Hello guys, let's do capacitor. Capacitor is the device which stores charge. The formula is C equals to Q by V. Capacitor does not depend on Q and V, depends on the dimensions. Okay, so it has one more formula which is C equals to A epsilon naught by D. Area, epsilon naught and distance. It depends on the dimensions, not on Q and V. So capacitor is the device which stores the charge. Okay, now next let's look at the energy stored. Energy stored equals to E equals to half CV square. Okay, see if the charge, okay, see I'm taking two capacitors. Okay, two capacitors can be parallel or it can be in series. Okay, see, first of all, if it is in parallel, this is C1, this is C2. C equivalent equals to, this is for parallel, C1 plus C2. You know in resistance it is, you remember if resistance for parallel is 1 by R equivalent equals to 1 by R1 plus 1 by R2. But for capacitance it's C1 plus C2 parallel. If it is series, in parallel voltage is same, and in series, if you know, the current will be same. So series is C1 C2, 1 by C equivalent equals to 1 by C1 plus 1 by C2. In resistance, right, resistance it will be R1 R2 is R equivalent will be R1 plus R2. It's quite opposite in series and capacitance. This is where they're going to twist the questions and ask you. I mean, it won't be twisted, you have to just know the concept. For parallel it will be C1 plus C2. Parallel means voltage will be same, so you have to equate using the voltage. And series, current will pass, same current will pass through the whole capacitance. That means it is 1 by C equivalent equals to C1, 1 by C1 plus 1 by C2. Okay, that's how you solve some. Before that, okay, see, there are two scenarios where voltage will be constant, current will be, the charge will be constant. When the voltage will be constant, okay, I'm going to connect two capacitance. Now what I'm going to do, I'm going to just keep it together. I won't remove that. If I'm not going to remove it, if I'm connecting capacitor to a battery, if I'm not going to remove that, battery is connected only. Battery is connected. If I'm not going to remove, the voltage will be constant. If voltage is constant, means the energy stored will be half CV square. Okay, and okay, I'm connecting the capacitor with a battery and I'm removing it. If I'm removing it, the charge will be constant. If it is constant, the energy stored will be Q square by 2C. You should know when to use this one, when to use this one. Next, so if I'm going to connect two capacitors, I'm going to have a common voltage, right? That common voltage will be V total or V common. Like when I'm going to connect it, it will be C1 V1 plus C2 V2 by C1 plus C2. So this is also one more formula. And energy equals to half C1 C2 C1 plus C2 the whole square, V1 minus V2 the whole square. So that's how you solve those questions.